Hey everyone, my name's Courtney and I'm here with Gloria, and today we're going to be talking about our Homework 3 problem for Engineering 460. So here's our problem description. You guys can go ahead and pause it if you want to look at it in more detail, but basically the gist of the problem is that there's a machine tool that needs to be scrapped every 4 years. So there's two options that the people can look at, and the first one is to replace the part whenever it fails until a scrapping time of 4 years, or the second option is to replace the failures during the first 2 years and then to make a preventative replacement 2 years from now. And we're looking to see basically which one would be cheaper to go with.
All right, now we're going to do the simulation in MATLAB. So I will be 1 to 5,000 because that was what the problem asked, to do 5,000 simulations. And because it was the exponential distribution, we're going to use negative log R1 times R2, and those are just two random numbers, and that's how we're doing our Monte Carlo simulation. So if there is a failure and it's still less than 4 years, we're going to count it. And I'm just going to run it to show you guys. So down here you can see the total number of failures was 8,704, and it's going to change every time you run it. See, if I ran it again, it's going to give me a different number. And the mean, they're usually on the same, 1.75. So that means for every part, if we had 5,000 parts, for every part, over the 4 years, you would expect it to fail 1.74 to 5 times. And now we're going to look at policy 2, and you can see that the iterations is actually 10,000. And this is because basically you're getting 10,000 new parts. You have new parts right in the beginning of the 4 years, and then after 2 years, you replace everything. And here, if y is less than or equal to 2 years. So if a failure happens and it's less than 2, we're going to count that as well. So let's run it. And the total number of failures was 7,500. For 5,000, I can do it again just to see. It's a different number, but it's basically around 1.5, which is less than 1.75. So as you saw earlier in MATLAB, for policy 1, 1.75 failures per part, and policy 2, 1.51 failures per part. But in policy 2, we're replacing all of them in 2 years. So when would policy 2 or 1 be preferred? So here CP is the preventive cost and CF is the failure cost, and 1.51 failure cost plus the preventive cost. And we don't know these numbers. If you go back to the problem description, is less than 1.75 failure cost. So basically down here, this line right here, if the preventive cost is less than about 24% of the failure cost, choose policy 2. So say to prevent it costs $30, but for failure it costs $100, then you would choose policy 1. Thanks for watching. See you next time.